This is a 24-volt roof-mounted air conditioning system. It is the largest thing I've ever had on the bench to test. It is claimed to be very efficient. Today, we're going to set up a test bench to see if this is a valid replacement for a complex mini split system. Stick around. Let's check the specs on this. CountryMod is the brand. This is a 24 volt. I opted for a 24 volt just to have something different. It does come in 12 volt though. 24 volt allows me smaller wiring and whatnot. This is a 10,000 BTU. It is an EER rating of 12. Puts out 270 CFM, cubic feet a minute, is the airflow. The opening you have to cut in your roof is 14 by 14 inches. I believe that is what's in here. Come on, man, use your strong hand. This is the seal for your 14 by 14 inch hole. You can only mount this horizontally, like this, flat. Can't be mounted on a wall. I was thinking about that. Be a cool way to install it. Total weight is 54 pounds. You have 15 feet of power cable. Noise. On sleep, this produces only 45 decibels. That is super quiet. I want to test that because the noise floor in here is 40 decibels. So if sleep is that quiet, that's nice. Eco mode is 50 decibels, standard is 55, and turbo is 60. Those are some quiet numbers. Current rating. Supposedly it pulls between 10 and 36 amps at 24 volts. The 12 volts a little different. I currently do not have a vehicle that is ready for the installation of this. The school bus build out there, it's not ready. But that's fine. That's fine because I think it's better to do some controlled tests here inside the studio shop where the environment is controlled. So while this is not a real world, it's in my van, I'm living with it type test, this will give you an idea of exactly the power draw, exactly how loud it is. This will be a good controlled test. Oh, one last thing. The list price from their website is $949. Okay, I will get busy on the test bench and we'll come back. The install is done. It took about 30 minutes. It wasn't terribly complicated. It's a lot easier than a mini split install, that's for sure. One sort of gripe, and I've reached out to the manufacturer about this. Manual is lacking. It's lacking a lot in the sense that it does have pictures, and thank goodness it has pictures because and it is in English, but they're labeled wrong. Now, this is obviously the outside unit and it's labeled inside and vice versa. And there is some wiring that you have to do, and the wiring is not described nor pictured anywhere in this manual. So they just leave you to guess and hope that you get it correct. And to be honest, the wires, the plugs on the end of the wires and the corresponding receptacle on the circuit board, for the most part, are all different sizes. So there kind of really isn't a way you could confuse them. But I do see some areas where if you weren't really used to that sort of work, you could put them in the wrong place, and I don't know what that would do to this. It could damage it. So your manual, you will be asking questions. Just go slow. Give yourself a day to do it. And here's our test bench. I have mounted this onto some sawhorses, and I will be laying under this for the duration of this to take measurements and that kind of stuff. This is not ideal because normally you would have the roof of your vehicle blocking and separating the outside noise from the The inside noise. So my noise measurements are going to be skewed. They're not going to be as accurate as if you mounted this on your rig. So what does that mean? That means that this is a worst case scenario. Once again, I'm measuring the total noise output of the inside and outside unit. Your installation will be a lot quieter than what we will experience today. My goal today is just to try and help you make a decision. Do you want a rooftop air conditioner? Do you want a mini split? Yeah. How did I power this? Because this is 24 volt. Let's talk about power for a second. A benefit to this system is that it is 12 or 24 volt DC, okay? And most of your off-grid batteries in your RV or your bus or your van are going to be 12 or 24 volt typically. So what that means is if you did a mini split, like a normal home mini split, they either run 110 or 240 volt AC, which means you have to invert. So you have to take the 24 volts or 12 volts from your batteries, invert it to 120 or 240 volt AC, and then provide that at the proper amperage to your mini split. No inverter, even the nicest, best inverter, is 100% efficient. So you lose some power when you invert it. So right there, it's a built-in inefficiency if you are running a mini split. This being, and I'm gesturing toward the unit, 12 volt or 24 volt already, there is no inversion step in the process. You can hook this directly to your battery bank, and as long as you have enough juice, enough amperage in your system to run this, it's going to run. That's one area where this unit has a leg up on a 120 volt or 240 volt AC mini split. For a lot of people, that added simplicity is nice. They can keep things all the same voltage. There's kind of a downside. When you raise the voltage, like when you go from 12 to 24 and then step it up again to 120 and 240, you can reduce wire size. You don't have to have such a large wire to push the amperage. So at 12 volts, it's going to require a pretty heavy duty wire to power this unit. Where at 24, you can get away with less the sizing. You can get away with a smaller wire and it's cheaper. And then when you go to 120 volt and 240, it's even smaller than running DC. But that's a one-time expense. Never have to bother with it again. So let's fire it up and see, and I'll show you what I'm using for power. I thought about taking some of my lithium ion modules that I'm going to use for the bus. These are out of a Jaguar I-Pace. I thought about taking these and building a battery for this, building a 24 volt battery. But I was like, that adds a variable. I don't want to do that. I'm using a 120 volt, or 110 volt to 24 volt switching power supply. It provides 50 amps at 24 volts. Please ignore the blue strap here. That's just holding the indoor unit in place because I didn't have anything to bolt to. This is your main control unit, or your main control screen. Power, fan up and down, mode, and then this is temperature up and down. It has cool, eco, sleep. That's turbo. I believe that's just fan. I need to do some reading and see what this power indicator is. Maybe it's a battery power indicator. There's these nice louvers that flip down and direct your air. Oh, it's putting out a lot of nice cold air. Looking at 12.4 degrees C, it's fairly quiet. This is on turbo. The outlet is 28.4. It's the highest I've seen it get, 18.3. It seems to be max draw on turbo. Yep, 18.3. Let's go over this remote here. It's pretty straightforward. On off, it's got a display. It shows you what your current set point is, battery life of the remote, fan speed. It's got your temperatures up and down, eco mode, cycle through the modes, fan speed here, cool and heat. I believe this causes the louvers to ramp up and down. Turbo is the strong mode, so if you want a strong mode. This is voltage. View your voltage. I don't know why you'd want to view voltage, but it can do that. This display here doesn't do anything. The backlight button also doesn't do anything. This has an electrical auxiliary heat, and then sleep pattern. That's sleep. It's on heat. Let's see what the auxiliary heat does. And here we go with the confusing facts. The remote, I believe, is generic. It works with other systems that this company produces, because even though this has a heat button and a auxiliary emergency sort of electrical heat, looking at the website description, because the manual doesn't mention any of this, this unit does not have heat. So that's rather confusing. This is just an air conditioner. It's not a heat pump. What you need to be aware of when you're purchasing this is $1,000. When you get in shipping, you're looking at a $1,000 purchase. And while a mini split heat pump is more difficult to install, and you have to have an outside unit and an inside unit. As far as noise goes, they're comparable. This unit is nice and quiet. All of the claims that they make on their website are accurate. They claim that it is quiet. They claim that it is efficient. The most I saw it draw on turbo was 18.3 amps at 24 volts. 18.3 times 24 is 439 watts. That's how many watts this was drawing at full capacity. Turbo mode with the temperature set to 17 degrees Celsius, and it was cooling. So if you have to figure, if you're drawing 439 for an hour at full capacity, that means that's 439 or 440 watt hours. So if you had a solar system that could produce double that, let's say you had an 800 watt solar system or a 1,000 watt solar system or something that could outpace it, you could run this during the heat of the day and produce more power in ideal sun conditions than this consumes. So the power draw on full is fairly low, and then it steps down from there. So their website claims are accurate, and I respect them for that. They indicate that you can run 12 hours of running on 112 volt 400 amp hour battery. Now that is on sleep mode, which is 0.3 kilowatt hours. I could see where this unit in sleep mode in a small confined space like a van or a teardrop trailer would be a great fit. Because when I had my ambulance, one of the biggest I'm getting very hot. One of the biggest problems I had when I was building my ambulance was the mini split heat pump. There is not a lot of room to hang the outside unit, and much less the inside unit. Now, the inside unit was nice and quiet, and it was relatively efficient in cooling mode only. those heat pumps are not really efficient for heating purposes, at least not where I live. They're okay to a certain degree, down to like 40 degrees, but you're not getting the best bang for your buck. You're much better with a small diesel heater. You burn a lot less electricity, and you put a lot more heat. That's just my opinion. Well, that's actually fact. In the winter, when you have limited sunlight, so you're producing limited solar energy, a heat pump for heat is not really a valid solution. Now, in the summertime, when you're killing it with your solar and it's hot, they're great for air conditioning. But they take up a lot of space. That's where I see this rig being very valuable. It's slim, so it only sticks up 7 inches off your roof. It is quiet. It is efficient. It doesn't require inverting, so you don't have to have a 3, 4, 5,000 watt inverter to run this thing, to convert your 12 or 24 volts up to 120 or 240 volts, like a mini split. So there is a lot to be said for all of those features. Plus, it's relatively easy to install. The manual does leave some things to be desired. And yes, the remote does have features on it that this unit does not have, like heat and turbo heat or extra electrical heat. And that is cause for alarm. I do not know what kind of after-sale customer service this company has, but they've been extremely responsive to me when I've asked questions via email. So for the $1,000, do I think it's worth the money? If your application is small, like a van, and you don't want to run a big inverter, and you're fine with taking up some valuable rooftop space for this unit, or you already have a air conditioner that you want to replace with a much more efficient unit, yeah. Is it the solution I'm going to put on the bus? Probably not. The bus has enough space, and we're going to have a massive solar system and enough inverting to run a dual zone mini split, because the bus is large enough that it would require 2, possibly 3 of these to do the job, and that takes up roof space that I want for solar. So no, I will not be running this on the bus. I might put it on a little shop trailer, something like that. I'll tell you what, let's take the lid off this thing and see what it looks like. I'm curious. Oh, it's pretty straightforward. Pretty much what you are looking at is this is your control module, your power module. This is your compressor and your coolant lines, your high pressure line, your low pressure line. And then this is your outside condenser coil, just turned down flat. This is your internal coil. And it is nice, it's insulated. It's pretty straightforward from what you would expect. I am curious here. This is a DC frequency conversion controller. Okay, reading the label on this, this is actually a 15-volt compressor. So that's cool. They're actually staying with a DC compressor versus doing something crazy with the voltage. Actually, the hoses look nice. The wiring is all sealed. The fittings look good. It's actually built quite well. It seems to be reasonably serviceable. There's a low pressure port there, so you could charge it or have someone check it or charge it if need be. The compressor is rubber mounted on shock absorbing feet, and that's nice. That means you won't hear the compressor rattling inside. I'm pretty pleased with the construction quality on this. It's made fairly well. So I've been hawing around here. What's my final verdict on this? For a large build, a bus, tiny house, something that's going to be 200, 300 square feet or more, I would not use a unit like this. If you had this space on your vehicle to do a mini split, I would consider that. If you had the space and you had the inverting, and you had the not necessarily the knowledge, but the willingness to learn what you had to learn and to buy the tools you had to buy to install it yourself, or you use like a Mr. Cool kit where they have the pre-charged line sets. That being said, if you have a van or something smaller, teardrop trailer, maybe not a teardrop because the roof is wonky, but if you had a smaller vehicle and you did not want to have to make a bracket to hang an outside unit, and you just wanted to replace an old, aging, inefficient air conditioner, or you wanted to add a relatively efficient and quiet air conditioner, I think this is a good choice. Yeah. Besides the fact that the manual is lackluster and the remote is misleading, besides those facts, it's worked flawlessly for me. And when it does reach your desired set point, it does ramp up and ramp down. So my measurements on noise and power is at its peak. It will not pull 18.3 volts all the time. It will ramp down once it reaches your set point. Oh, and I should touch on noise. Below the unit on high, I measured around 61 decibels. That's right in line with what they said. On low, I could see, or on eco mode or sleep mode, they claim 45 decibels. I could easily see that being achievable with this unit. With my setup in here, I won't be able to because I can't separate the outside noise from the inside noise. I'll put links in the description to all of this. If you have questions or want me to go into more details about anything that I experienced with this, let me know. I'm on the fence about this one. I think it's reasonable value for money. I've had experience with mini splits, and I had a lot of good experience running a Pioneer mini split. I had a 9,000 BTU, 120 volt mini split in my ambulance, and that worked really well. This being a 10,000 BTU unit, it should be okay for a small space. So if you have an ambulance or van, flat roof, yeah, low profile, worth a shot. All right, I'm Jason. Thanks for hanging out. Questions, concerns, comments down below. I hope I helped you make a decision. Yeah, if you would subscribe, I'd appreciate it. I'll catch you later.